Hello there, my friends. Welcome to Drone Technology course by udroneanywhere.com and Udrone Anywhere Incorporated. Module 1, Aerodynamics. So, on the very start, we would like to let you know aerodynamics is more like the underpinnings of aviation. And having said that, I'd like you to ask this question, but please don't sue me or don't take me to court. Have you heard of this saying? If you ask a bank robber, why did you rob a bank? And then he turns around and replies you, that's where the money is. With drone development happening by the minute, I would say aviation is where the money is. And having said that, I'm going to give you another example. I know you are my students and not my wife. She's going to tell, well, why don't I get into the subject rather than going into a tangent? But this is important. See, what have you heard about the reputation of a commercial pilot? Well, I'd like to let you know, I'm not talking about the prestige part of it, but the work ethics, accountability, discipline, and the skill set of a commercial pilot that is has made a mark in the society. And on our module 8, what we give a total guidance to sit for the remote pilot license or examination conducted by FAA, Federal Aviation Administration. For just $150 you can get the license, remote pilot license. And if we don't get it for that much of that little dollar amount, we are silly, right? Yeah, talking about commercial pilot's reputation for a quarter of a century, being in at least started my career in aeronautical engineering. I would say only one incident I would know for 25 years. This happened in LaGuardia Airport. I think at the takeoff, the plane ended up in the lagoon. I think it's not among the major airplane disasters because I think nobody died. That's why. But in the investigation, that it was revealed that pilot and the co-pilot was sitting in the bar. Maybe they were just drinking cranberry juice, but the optics that you leave behind may not be good. But other than that, what I'm trying to say is commercial pilots' reputation is so high. When you get your remote pilot license, you still would get some part of that reputation because. To become a pilot, you have to have accountability, discipline, skill set, and a responsibility. So, equipped with that, and knowing aerodynamics and following the other modules of the course, you will be out there to make good money, big money, or good money, so to speak. So, listing out the figures list, I will get the camera focused on our displays and we'll go through that. And along with that, we have to, unfortunately, we say let's do away with paper, but we still have to refer to paper. For me, as far as I'm concerned, that is my teleprompter, so to speak. Just bear with me. So, ladies and gentlemen, we will go through these figures. In fact, if the resolution is not good, they are all in our website udroneanywhere.com. But as reference, we will give it to you over here, and then of course once you can download it from our website, and some of them we refer to the aviation manuals that are provided at least available to download from FAA website, or you can browse through, and wherever needed we are giving reference, like for example pilot's handbook of aviation, and it's marked pilot's handbook of aeronautical knowledge, and we will give you reference as necessary. And beyond that, even if you find something like you need to check out, you can always come up on the chat program. We have the 24/7 chat program. That's one of the things that most other people may not offer. And in fact, as a special going on now, we are giving just for $25 you can start on the remote pilot license course. But yes, anybody would ask why we managed to give it such a low price. But the fact of the matter is we would like to make the money at the back end when people take the whole course, and what we have to emphasize to you is because we have the chat program going on, in case you have any difficulty or any question, you can come up on the chat program. Okay, now if I go with the list of the figures for module 1, the figure 1 will give a text of this audio. Figure 2, list of figures of module 1 is listed out on a PDF file over there on figure 2. Figure 3, all the different useful links, we have a list of that. Figure 4, once again, like this you may not see perfectly, but you would see in the, let's say, figure 4, airplane parts. This is a NASA image, and we'll be describing that in a lengthy way. Different parts of an airplane, or different gadgets, or you can call it different services. So we'll be going into detail on that. And then you got on different figures. Just bear with me on this one. Yeah, figure 5, we would be going through in detail all different names of different activities or controls or other descriptions on that, and so that anytime any name or identification is given, we would know, all the students would know what we are talking about over here. And then let's see what we have on figure 6. Figure 6 has shape of the wing. Yeah, we'll be dealing with that. Yes. I just set it to here, shape of the wing. Yeah, shape of the wing we will be dealing at length. And figure 7, where it's Venturi tube. Yes, figure 7. That's the Venturi tube. And then figure 8, four forces of light. Of course, we have to deal in length of, that's the four forces of flight. And angle of attack, figure Let's see now, angle of attack. Yeah, figure 9 we'll be dealing with angle of attack. Figure 10 we have a side view of a rotary wing. Yeah, that's the side view of a rotary wing on a helicopter. And figure 12 we have a swatch plate. Swatch plate is also, we will be dealing and understanding it in a proper way, of a solid understanding of that. We need that. Yeah, that's figure 11, swatch plate. And then figure 12 we got a rotary diagram of a quadcopter. That's a rotary diagram of a quadcopter. It indicates the directions, and we have another diagram later on coming up. Clockwise, number 3 rotor clockwise, number 4 rotor clockwise, and 2 and 1 are counterclockwise. We'll get into that as we go on in the course, no doubt. On figure 13 we have listed out the negative effects of excessive weight. We will be discussing through and through on that. And figure 14, yeah, figure 14, once again the description of airfoil, and understanding all these names: camber, thickness, mean camber line, and chord, etc. Figure 15 will show you the aspect ratio and the different wing shapes. Once again, a detailed discussion would be done with that. On figure 16, yes, what we have here is gyro effect. Once again, we'll be dealing with that. And on figure 17, we got the precision of gyroscope. Figure 18, we will be dealing with different types of flaps. Yeah, figure 19 will have the cross section of the wing with the more identification on when we are dealing with the angle of attack. These names would keep coming up. Yes, figure 20 shows the adverse yaw. And what do we have on figure 21? Figure 21 and 22, helicopter torque reaction and anti-torque reaction. Pardon me, this word torque I'm not really pronouncing well. Let's look at those diagrams. Yeah, my friends, these are the diagrams of torque, and let's see the other one, anti-torque. Okay, this is the anti-torque one. It's very important to understand on the helicopter how the tail rotor stabilizes the aircraft. And figure 23, once again, helpful to understand the on a quadcopter how the props or motors arranged to rotate in clockwise and anti-clockwise direction. Okay, now what we have on figure 24. Yeah, it shows the propeller arrangements for hexacopter, and then we will go to figure 25. Oh yes, we keep adding the props. This is an octocopter, and then the arrangements of the propellers for that and the directions. Yeah, the last figure we have is the figure 26, the arrangements of the control and the props of a quadcopter on the mode 2 arrangement. We put it the mode 2. That's the more common one, but most of the controls now you can they are switchable between mode 1 and other modes also coming up as development happens on a rapid pace. Here, if you observe, the throttle is on your left hand side, and of course we are going to get into details of that. Yeah, ladies and gentlemen, as we go on the very start, there are a few basic things that we have to cover, mainly Newton's first law, and also Newton's third law of motion. First law, of course, it says all objects remains at rest or travels in a constant path and a constant velocity unless otherwise compelled to do so by forces acting on it. And then, of course, Newton's third law of motion, every action has an equal and opposite reaction. So then we have to couple it with Bernoulli's theorem and Venturi tube when it comes to try to understand how the shape of the wing and the pressure difference between the bottom of the wing or underneath the wing and on top of the wing, helping an aircraft to take to the air. And also it's equally important to understand when we talk about pressure. It's very interesting. We call it pressure in terms of atmospheric pressure, barometric pressure, and then we also say it as density pressure as against now I want to emphasize this as against when we say pressure underneath the wing and above the wing. It's still we are dealing with pressure, but we are trying to understand something different in terms of the concept itself. But pressure itself is pressure, no doubt. If you define just the meaning of the word, then let me pull out one of these diagrams which will show us a shape of the wing again and the airfoil description. We are going to come across these words continuously: camber, main camber line, chord line. Those things will keep coming up, and I would also want to deal at this point the four forces of flight. Let's get into that figure. Yeah, this is a figure for four forces of flight. The NASA figure, all compliments to NASA. Now, once again, we have to remind ourselves the Newton's third law of motion. Every action has an equal and opposite reaction. If you see the four forces, you got the thrust coming this way when the plane is flying forward, of course, and it has to battle the drag. We'll be dealing with the drag in so many different drags that I would say is in existence of an airplane. Has to deal with, and then invariably the weight is there of any object. So against weight, you have to have the lift working on to get it airborne. Then once again, I'm going to flip into another diagram of the airfoil. And ladies and gentlemen, as you said before, the shape of the wing is a large part, is helpful to take a fixed wing aircraft to the air. See how it is marked. Increased pressure underneath, got low speed, and above it's reduced pressure and becomes high speed. In other words, that helps the wing to get lifted and also tilt it a little bit so that when you move forward, it makes it easier to take to the air. And on these layers, we are going to discuss more on the shape of the layer. There are 2 layers that we would be, in fact, 3 layers, or the boundary layer. There's something happening to the boundary layer. We will show it. We want to keep it what you call a laminate layer on the boundary layer, but unfortunately, at one stage, it becomes a turbulent layer, which is which is problematic. But then the designers of the wing always try to keep it as much as possible, the top layer of the wing, as a laminate layer. But then we will, at a later stage, we will be dealing with angle of attack and the stall. In fact, when we do the Module 8, where we detail and prepare students for the remote pilot license, I would even say, like, it is imperative that you understand the angle of attack and the stall situation, because FAA looks like it's more like absolutely FAA. You can say the protocol demands that you understand the angle of attack and the stalling, because I'll assure you there's definitely going to be 2 questions on that. And it's almost like FAA tells you don't even come anywhere near aviation if you don't understand these 2. The whole hell breaks loose if you don't understand the angle of attack and stalling. I hope FAA will not take notice of how harshly and aggressively I put in this, but it is important that the students understand those things thoroughly, so that there is no need to second guess. Having said that, even in the first time around you find it difficult to understand, do not worry about it. Admittedly, I found it difficult to understand in the first shot. I had to spend some time to make myself to the realization of angle of attack and stalling. So let's at this point we see the diagram of aerofall, and let's go a little further into this. So then, what does the Bernoulli's theorem tells us? Yes, on figure 7 we see the Venturi tube. It could be air, it could be fluid. The same thing happens if the diameter where you send the air or fluid is one level over here, and it is lower at a middle position. As the pressure becomes lower at this point, the velocity becomes higher. So that is the Bernoulli theorem, defined and displayed on Venturi tube. So I'm sorry, we have to go back and forth. That's the nature of this aerodynamics, understanding aerodynamics, how it works. So I have to get back to this 4 forces of flight diagram to explain to you engine thrust and the drag. It's the engine of the plane. If it could be propeller, it could be turboprop or jet engine, makes you move forward. Okay, you're fighting the drag. So thrust of the engine we gotta remember how that works, and let's get into the next part. Is another diagram to show the chord and camber line. And yes, this is figure 19. You see the mean camber line. It's a curved line between the leading edge and the trailing edge. Yeah, you got the leading edge over here, trailing edge over here. Camber of upper surface, camber of lower surface, and chord line is not the curved line but a straight line. And in fact, this is you can we have it as our own. We have it as on our website as figure 19, but on FA, a pilot's handbook of aeronautical knowledge, you have that. In fact, that's how we downloaded that. So once again, we should have a solid understanding of these identification and definitions of different descriptions. Okay, ladies and gentlemen, let's try to understand all these parts and services or gadgets, if you may call it so, on the airplane. So we get a better understanding of aerodynamics. Okay, you have here ailerons on the wings itself that could be pilot would be moving them around to change the roll. I would also show it along with well, I ordered a nice little aircraft from model aircraft from Amazon Prime. They haven't come. I haven't got it yet, but hopefully they don't ring the bell right now and disturb my recording. But even if you think about the drone, like you have aileron effect of the airplane is the roll effect, like it banks like this or banks like that. So that's the aileron effect. It changes the roll, and we are going to treat flaps as a secondary control, and we will be dealing with that also later on. And then you got the change of the pitch, makes it go up and go down. That's the on a fixed wing aircraft, you do it with the elevator. And the rudder movement is the movement on the vertical axis. So in other words, you whether it's a plane or the helicopter or the drone, we are talking about the movement of on the vertical axis like this. And pitch, I forgot to tell, pitch is the lateral, the movement on the lateral axis. That's in this direction, and the roll is on the longitudinal axis. Forgive me if I'm not pronouncing that word properly. Longitudinal axis, that is rolling this way and that way. So those are the different movements of the plane that is needed to maneuver it. And also, ladies and gentlemen, I want you to also want you to observe this winglet decreases a drag. And in fact, at this point, I would like to bring the fact that initial planes did not have this winglet, and if you fly any commercial plane today, you will, if you sit by near to the window, you will definitely see this small jutting out portion, like one of these at the end of the wing, where two designers had to deal with what they call wingtip vortices, and then that's how they got at least got that under control. We'll be having a long discussion on that too, and let's move on. Yeah, my friends, I also want you to observe the horizontal stabilizer and the vertical stabilizer. Horizontal stabilizer, where the elevator is mounted on, and rudder is mounted on the vertical stabilizer. And some of the planes, you have the V-shaped tail end that acts both as the vertical and horizontal stabilizer. And ladies and gentlemen, at this stage, I want you to understand what they mean by adverse yaw. In other words, when the plane is rolling on one direction, there is a tendency for it to do a change on the vertical axis. That's a yaw change in the different direction. In other words, plane is trying to bank on the towards the left hand side, but it has to, the pilot would have to make sure it's gradual control by putting the controls in a way so that you smoothen your banking, because there is this adverse yaw effect that it's trying to swing on the vertical axis on the other direction, like it tries to be on the vertical axis and to change on the reverse direction. Okay. Yes, ladies and gentlemen, we were talking about the drag and the thrust of the engine will push the aircraft forward, fighting the drag, and then we would be talking about number of different drags that will affect a fixed wing. That is there is one definition called form drag. Form drag is any shape of the aircraft. There is a certain amount of drag, depending on, of course, the designers try to make it as less as possible so that it is easier to take off and be on flight. And form drag, you can call it the shape of the aircraft is present because of the shape of the aircraft, and induced drag, and as we discussed, the wingtip vortices are due to induced drag, and we discussed how the designers lately has minimized it because of the new designs. Yeah, speaking of new designing, in fact, just a few months ago, I saw NASA head giving a lecture on the idea of getting rid of the whole fin. That if it is a jumbo jet, you are talking about removing about 8 tons of the plane, because he was explaining, like, if the birds do all the flight maneuvering without fin, we should be able to do that. Why I am bringing it up at this point is the development keeps happening, forever to improve the flight methods and conditions and make it easier to fly. Getting back to drags, if you talk about the next type of drag we're going to talk about is the induced drag, and how designers control that is from with the aspect ratio, that is the ratio of wingspan to the wing chord. But also designers had to grapple with the fact that you do have a larger aspect ratio, but at the same time the wing they may have to make the wing larger. If the wing is larger, of course there is more weight, so it's a give and take between those two, that the designs differ. Because of that, you will find all different shapes of the wings, factoring all that, and make it as efficient as possible. Another important thing on the drag is the skin friction drag, mainly in countries where winter you have to go endure the winter. Shall I say that? Is it okay? Is it a okay sentence? Yeah. And then if snow builds on the wing, that definitely is not a helpful thing for the plane to fly. So when you have very smooth surface, you have only a very little amount of skin friction drag. And what is the other drag we'll have to deal with? How about the antenna masts plus the wheels, undercarriages, all those brings in a drag, so that is known as parasitic drag. And also there is another thing that we need to deal with, that is so slipstream, mainly from propeller aircraft. Wind keeps with the rotation of the propeller, the wing keeps hitting the fin of the aircraft, so there is tilt factor, at least at the fin and rudder. So then there is a certain amount of tilt done to the on the fin to offset that situation. In fact, this is mainly a single engine aircraft. If it is a propeller engine, the effect is more. But because if it is twin engine or four engine or multiple engine, the wings will balance out that slipstream. And how about the jet engine aircraft? Jet engine also, there are a single jet engine aircraft like fighter planes. I know jet pros, they used to use in RAF, Royal Air Force, that was designing from 54 to 67, I think. But the intake is on two sides of the fuselage, and on that plane, you don't really have to deal with that kind of slipstream, because the exhaust goes out beyond the fin. So that takes care of that situation. Now we discussed about the longitudinal axis, lateral axis, directional stability, directional axis, that is the yaw. And I want to bring up another diagram here. Yeah, this is figure 6 again, the aerofoil. And on this, again, I want to get your attention on the center of pressure. When they want to designers want to keep the center of pressure as much as possible, like it is on laminar layer rather than going into the turbulent layer. And also the center of gravity, how that affects the flight. I'm going to show that also. Yeah, let's see over here when center of gravity is important to remember. See, in an aircraft, it's marked center of gravity limits. The, those things, as it is marked over here, front seat, rear seat, it's an important factor to keep the aircraft safe under guidance of weight and balance. And then I'm going to show you that other chart that we have put together. Yeah, these are the negative effects of excessive weight. Some of them, just like common sense, like higher takeoff speed, longer takeoff run, reduced rate and angle of climb, lower maximum altitude, shorter range, reduced cruising speed, reduced maneuverability, higher stalling speed, higher approach and landing speed, longer landing roll. So, but it's important to remember those factors too. So that is the figure 13. We have that list. Right. Let's go into, yes, not another area, but more definitions of words. Like whenever you hear the relative wind, that is parallel and opposite to the flight path, you got to always remember that. And we dealt with the aspect ratio. And one other factor easy to understand is lift acts against the weight. So an aircraft cannot leave the ground if the weight is more than the lift. And with the wing effect, pressure underneath the wing and above the wing, we get to a situation where the lift is more than the weight, and that's how a plane gets airborne, as I keep saying. Yeah, on angle of attack, pilots always try to keep it less than 15% without exceeding the danger area. Yeah, I'm sure now when you fly on a commercial flight or even a private flight, if you have any of your family friends take you in a Cessna or something, you will see these flaps. The pilots move the flaps around. You see so many different types of flaps: plain flap, split flap, slotted flap, Fowler flap, and then fixed slots. What is in front, pretty much again helping to maneuver. Fixed slot, movable slot, leading edge flap. So those are different secondary controls that are very useful for pilots to maneuver the plane in a way it is safe and not a disturbance to the passengers or the pilots. Yeah, speaking about atmospheric pressure or density pressure, you will hear the figure 29.92. That is the pressure on sea level that will come over and over again, even on air traffic control. So very important to remember that. On the design of wings, yet another name I would like to present here is the dihedral design of the wing. In other words, at the end of the wingtip, end of the wing, that is the wingtip, may be little slanted towards a higher angle, at a higher position than the start of the wing. So that's again relating to induced drag and to reduce the vortices. And also an important point to remember on the flaps helps and change lift and drag. You can get the flaps to position it in such a way if you need shorter run for the lift or higher lift and things like that. Also helps to smooth and help for a smooth and quick landing. I think I have observed many times on commercial flights how the flaps, the pilot change the flaps just before landing. So you might even be observing these things on a regular basis when you fly now. And there are spoilers also. Even cars got spoilers, so that's also whenever you want to change the drag and change the lift, you can use that. And there's another secondary movement called anti-servo tab, which smoothens the stabilizer movement. Although we will not be dealing in length, now generally you got an idea of what's equilibrium. Any parked aircraft or travels in a constant path in one direction, it's then you assume that the plane is on equilibrium. Not when it takes turns or rolls. No, it is then it's whatever you do that. Or it could be wind if turbulent, and then getting back to whichever path without changing directions, you call the aircraft regaining the stability. Okay. So let's turn into figure 16 and talk a little bit about the gyro effect. What we have here is, you can see the same thing on Pilot's Handbook of Aeronautical Knowledge, figure 8-18. I would really want to spend time on this one because as drone pilots, you will be dealing with the cameras mounted on drones, and then that also is a gyro effect thing, your gimbal. In other words, the platform itself will be pivoting, changing directions, but the object will keep into the same position, regardless of the platform it's pivoted on is being moved around. So it comes in very much useful on flying the plane, in terms of keeping the correct attitude, and at the same time we have to understand when the engine is moving the propellers, there is this gyro effect or precision of gyro effect that we will have to deal with. I'm going to show the figure 17. What this says is, when you apply a force, external force to something that is rotating, it acts as if that force is applied 90 degrees out of phase, as you see in this diagram. It's very important to understand that as part of aerodynamics, plus using of the gimbals and your cameras, that comes into play too. Okay, let's talk about torque and anti-torque on particularly in helicopters. As I said, now that we have got the basics on the fixed wing, we are not going into too much of details on the helicopter, but I would like to lay it out to you the fact that initially on the design side of the helicopter, the designers managed to get it airborne, but it was revolving on its own axis vertically. That is the part that designers found it difficult to control and took a number of years before they came out with the design of the tail rotor, which handles the torque with its anti-torque capability and make the helicopter stable and viable to use it as a flying machine. So those two diagrams, if you look at them, that's important to understand on the helicopters. And let's move on to the real subject, I believe, then on drones. If I didn't explain to you before, usually when you go from stage 1, stage 2 to stage 3, it's the usual thing, it becomes difficult. But starting from fixed wing aerodynamics and then going into helicopters and getting into drones, it's fascinating. It becomes not difficult, but it's easier to understand. See, the basic quadcopter, the format of the rotor's direction and rotor direction, or even the motor direction, we can very easily or simply understand, because if you have on the quadcopter you have 4 rotors, then look at this, 1, 2, 3, 4 rotors. What is diagonally 1 and 3 goes on clockwise direction, and 2 and 4 goes the other direction and attains stability. And then of course you have all the movements. You can do the pitch to climb and roll to roll on the direction on longitudinal changing, and then you can do get the rudder effect on changing it on vertical axis. So how does the drone achieve all that? Just for 4 rotors, changing the speeds, you can achieve all that. In other words, you can achieve pitch function, you can achieve roll function, and you can achieve yaw function. All the functions could be achieved just changing the speeds of the motors. So thereby we're doing all the maneuverings. Ladies and gentlemen, you know what I forgot? I have to bring up this diagram. That's the figure 11, swash plate. See, in a helicopter, to get all this maneuvering, you have to seek the help. You have to seek the help of the swash plate. In other words, the blades, the rotor is revolving at such a high RPM. At the same time, it has to change the pitch. So changing the pitch with such a high RPM meaning it has to, the metals or material has to sustain so much of stress. So now you got the picture. On drones, you eliminate all that because there is no swash plate needed. Just change the speeds of the motors, and you achieve everything without that strainful mechanical activity that you have to perform on a helicopter. Speaking of that, it brings me to the blade, shape of the blade, and the word pitch. You see, ladies and gentlemen, we always, not always, at times, like we were describing the word pressure, how it is means the same thing. At the same time, it is applied to describe a different situation. Like the pitch, if you check on the dictionary, it will say one meaning, but here when it comes to the pitch of a helicopter or fixed wing plane or even on the drones, we have to understand something something very particular to a wing pitch. I'm going to show that in a very simple rudimentary way. Just bear with me. See what you see here? Just a piece of just a nail put on a piece of wood. What I will do here is, at the moment there is no jutting out portion or anything jutting out from the surface of this. Okay, where was I holding it? Oh boy, sorry. Yeah, there is no jutting out portion from the screw. And what I want to do is turn in 360 degrees on this. Go round, go round, go round, go round, go round. Now I have turned 360 degrees. So what the pitch means for a blade is how far forward it came. You see, it has come out a tiny bit, maybe 1 millimeter, 1/8 of an inch in the United States. Okay, so that is what it refers to, a pitch of a blade. Doesn't matter whether it is a fixed wing aircraft, doesn't matter whether it is a helicopter, doesn't matter whether it is in a drone. When you talk about a pitch, that's exactly what it means. So we got that out of the way. So there we are. We got the basics of aerodynamics, and there would be a recap. Recap would depend on the feedback that we get from the students. Once again, you should get on to chat if there's any area that is difficult to understand, that we will correct that situation. And also on the list of diagrams, there are always we move them around, put in new diagrams so that it could be understood better. So if the diagram, at least the figures, if the figures doesn't exactly correspond to what is in the audio, so bear with us. We might have it could be the reason that we would have moved them around, but still won't make it difficult for people to understand it or get the students confused. I thank you very much, and we will see you in module 2, that is design concepts and tools of drone. Or I said it wrong. The title of module 2 is design concepts and tools of drones.